Everyone, and good afternoon to somebody on the East Coast. My name is Clint Kilborn with Leviat, formerly known as Meadowbrook, Halpin, and Thermomass. And we have a lot of information to get through. I'm going to try and get through it best I can, and hopefully answer all your questions. Please feel free to include, any notes or questions, comments, and we'll make sure to get back to everybody as soon as we can. And hopefully we'll have time at the end of the webinar to do that. I hope everyone can see my screen okay. With every meeting, I always like to start off with a safety minute. There's no good reason to make a bad decision. This picture was taken from Russia, actually, and you can see there's a lot of problems with this. No hard hat. There's a concrete panel over this person's body, and there's nobody in the lift there. So lifting and erecting are critical operations that need to be properly planned to minimize risks. So a quick note out of OSHA, for every 3,000 hazards, you will have 300 near misses. And of those 300 near misses, 30 will result in worker injuries. Of those 30 injuries, 1 worker will die. So the basic idea of this is you eliminate the hazards, you eliminate the misses, and you eliminate fatalities. So, something as simple as you see as an extension cord in a walkway at a precast plant, get it out of the way and you eliminate the misses and so forth. So the agenda for today, so there's an objective of lifting and handling. So we're going to go through the types of lifting systems and hardware, how to determine your safe working load. There's basic physics of lifting, safety best practices, and there's going to be some key takeaways. So at the conclusion of the course, you'll be able to define different styles of lifting hardware, the equipment and their applications. You'll describe the impact of concrete strength on lifting hardware and their capacities, differentiate between a safe working load and an ultimate load, and describe the basics physics of lifting, sling angles, number of lift points, center of gravity, and identify the signs of wear and damage on hardware and equipment. And also outline the safety best practices for lifting and handling. So there's several types of lifting systems and hardware. First of all, lifting systems. Basic idea is that you have an anchor, a recess member, and a clutch. The anchor is the element that's cast into the concrete. It's your connection point between the element and the lifting gear. You have a recess member, which is the void to create the engagement between the clutch and the anchor. It allows for enough clearance around the anchor to attach the clutch, and it can be disposable or reusable. Then there's the clutch, which is a reusable element to securely connect the anchor to the sling, and it's rated for different capacities, rated for different clutches. So as you can see in the picture, I don't know if you can see my mouse, but there's a there's a stamped steel type clutch and a dog bone type clutch. So installation, it's pretty simple. First of all, you want to keep your recess members clean and greased after use. For the reusable ones, you crisscross it with either a rod or this thread nut here, and you insert the anchor. Once the anchor is inserted in the recess member, you attach to your form. Could be a wood form, steel form. You could have a magnet plate. You could use this wing nut that's shown in the picture here, or in the 2B, you can see the picture with the recess member with nails, and you can just nail it to your form. Once you put that in your form, you're going to add additional reinforcement as needed. So in this picture, it shows a shear bar. There could be a tension bar as well. Once the concrete is poured, you're going to attach the clutch and lock the ring clutch in, and you're safe to lift. So installation, so concrete, this bed in the picture on the left here, step 1, it's a typical pre-stressed flat panel bed. You see some embeds, you see other components, you see the reinforcing. Once you have all that in, you're going to put in your lifters, and you're going to attach to your form. They're bolted to the form in this case, and you're going to add tension bars. You can kind of see this V anchor, or I'm sorry, not V anchor, but a V-shaped tension bar. And you can't really see it in the picture, but there is a shear bar going across there as well. So there's different components that you'll need to install. Once the reinforcing and erection anchors, weld plates, structural connections are in place, the panel is ready to be poured, and then they're going to generally pour the panel from one end to the other, depending on the type of concrete they use. So there's an engineered lifting system, which it contains three components. You have your clutch, your recess member, and your anchor. The uses for these are panels, beams, double T's. It could be infrastructure. There's a lot of different uses for these. The advantage is they're high strength. They're engineered to achieve a safe working load with the anchor, recess member, and the clutch. All three are designed to be worked together to create that safe working load. And you can increase capacity with reinforcing. Another engineered lifting system is commonly referred to as a dog bone anchor, basically due to the shape. So you have the anchor, the recess member, and the clutch. It's typically used for panels and beams, could be used for infrastructure as well, for various types of concrete elements. The capacity is due to the foot of the anchor, the length of the anchor. You have the pull-out strength increases with embedment, and it's engineered to achieve a safe working load with anchor, recess member, and clutch. There's also hook lift systems. So there's different varieties of hook lift systems, commonly used for infrastructure precast. They're high strength, they're engineered with a recess member, and they're lifted with a utility hook, typically a 5 or 7 ton hook. It depends on the size of the recess member. So different manufacturers will offer different recess members to use for different hooks. There's also a lift pin system. It's commonly used for infrastructure precast, for quick and easy picking. So there's different ways to do this. You have a socket and a pin. The socket can be put into the concrete with dry cast or wet cast, and then they would be inserted with a pin. The other way to do it would be to drill out the concrete and hammer in the pin. You could also epoxy it in. So the advantage of this is basically what this pin is it's a rebar over molded with high density polypropylene. Low capacity, low price, but it works really well for precast plants. It's very easy to transfer with forklifts, hooks, or chains. There's also the loop lifting systems. So there's a variety of manufacturers that use these. It's commonly used for infrastructure precast. You'll see it sticks out of the concrete, kind of denotes the yellow marking. Low price, low capacity, but it depends on the capacity and embedment of the anchor, and it's commonly used with a hook. Last system is the plate lifting system. These have a variety of terms. Most common is called the panic plate, and the reason for that is you use this system as a last ditch scenario where a plate or a lifter is missing or misplaced. So if the precaster forgot to put it in the anchor or got buried in the concrete, you can't find it, and you need a lifting solution, this is a great one because it's very high capacity. It can be used with post-installed anchors. It works in tension and shear for rotation. So, but there is a bit more work to it, and yeah, this is kind of a last case scenario, but if there's any questions, please let me know. Additional hardware. So in addition to your anchors, you're also going to have spreader bars, rolling blocks. A spreader bar, it helps equalize the balance. It's a stiff steel beam to transfer multiple pick points to one location. So you kind of see in the picture here, you have rolling blocks as well. You have your crane, you have your spreader bar coming down to rolling blocks, and then the rolling blocks, what they do is they equalize the load on the slings. This is pretty common in a precast plant. You see a rack with chains and slings on them for different applications. There are several different types: single leg, double leg, 3 leg, 4 leg. And I'll get into a little bit of this as we go through, but you know, 4-leg, you got to use caution because there is a change as far as equalizing load when you use 4 legs coming off of one shackle. 3 legs is ideal for, you know, smaller lifts, and it really does equalize the load. It's kind of like a 3-legged bar stool. So how do you determine the safe working load for precast concrete? It's kind of a riddle. For some of you that read through the presentation that was sent out to you, you might already know the answer. So a bat and a ball costs $1.10 in total. The bat costs $1 more than the ball. So how much does the ball cost? I'll give you just a second. So the answer to this, I bet a lot of you said 10 cents. And the answer is actually 5 cents. So you add $1 to 5 cents, $1.05 equals $1.10. This was actually come up with by MIT. It's called the cognitive reflection test. There's multiple riddles like this. The idea, you know, you say, well, what does this have to do with precast concrete and lifting and handling? And the point of this test is you move past impulsive answers to deeper analytic judgments. And what I mean by that is a guy in a precast plant might say, well, we'll just put the anchor here. You know, we're not really looking at the drawings, or we'll just use this shackle or this hook or this clutch, and it'll be fine. Well, you want to think about it a little bit deeper than that. You want to move past that and get to a judgment that will safely lift and handle your precast concrete. So planning and design. So the most important step is proper planning will dramatically minimize risk during handling. And that's really important. I mean, these are life safety products that you know, really impact people. So the basic step on the left is you identify the size and the restrictions. So what I always go back to with precast plants is, what's your weakest link? Is it your hook? Is it your chain? Is it your anchor? Is it the concrete? Is it the spreader bar? So you kind of have to analyze what is your weakest link. So crane capacity on the plant and job site, you have your transportation size and weight, you have storage space, you have site constraints, and before the elements are sent to a job site, it should be assured that the construction is ready to accept them. You don't want to show up at a job site and not have a place to put your concrete elements. You also want to position your lifting points. So keep member stresses within limits, especially in the exposed face. Consider the entire process from stripping through handling and erection. Members with eccentric elements, different sizes, shapes, holes in the wall like this, may need additional lifting points or strong backs. Strong back is this picture here. You see the steel here plate, helping minimize the risk with the opening. So there's several different design codes and standards. The main one is OSHA. And so the codes cover multiple aspects regarding lifting and handling of erection of concrete structures. There's an applied load, a capacity of structural elements. There's best practices and detailing of the elements. And there's design limits. So NPCA does a great job with webinars like this. You have technical information, multiple learning tools and resources. OSHA has a very specific standard on lifting and handling. It's 1926.704. If you put that into Google, it'll list out everything as far as what the standards are, and there's requirements for precast concrete. The PCI Handbook, Chapter 5, also does a good job of product handling and erection, best practices and design consideration for elements. So any one of those, I mean, OSHA is kind of the gold standard as far as precast concrete goes. Design considerations. Okay, so when selecting and designing anchors for lifting and erection process, the following aspects must be accounted for. So you have your applied loads, and I'll get into that, your anchor type, capacity, your concrete age, your edge distance, your rigging configuration, and one thing I probably should put on here is your sling angles. So the quantity of inserts needed is best determined by the precaster and shown on the shop drawings. It's really important that the shop drawings show where the lifting inserts are to be placed. Connection hardware for in-service should not be used for lifting handling. And what I mean by that on the bottom is you don't want to put like a coil insert that you're going to use for bracing to also be used for lifting and handling. So that's not what it's designed for. And so you should use a separate insert for lifting and handling as opposed to bracing or permanent connections. Sorry. So there's different applied loads, like I talked about. There's a shear load and a tension force. So a shear force is a force acting in direction perpendicular to the anchor length. There's also a tension force acting in parallel to the direction of the anchor length. So you might say, well, obviously the tension force gets a little more production out of the shear force, and it depends on the anchor. So there is different applications, and there are different ways to use different types of anchors to make sure that you're getting the appropriate load. So in addition to the weight of the concrete, there's also other things that need to be considered. So what I mean by that is there's form sections. So any of you who've been to a precast plant or like a tilt site have seen as you erect or pull out the concrete element, you're going to see an initial pop off the form, and that's called the form suction. So this can range from 20 pounds a square foot to 70 pounds a square foot and beyond. There's also a shock load. The picture on the right, not every precaster has a perfectly level yard, so you might end up with a hole or something that it bounces over, and that creates a shock load. So there's a load amplification from the transportation. There's also applied loads. This is put in the PCI handbook, table 8.3.1. So you have a finish of exposed aggregate versus a smooth form. That's not really what I'm focused on. What I'm focused on is that there is an additional element to the concrete piece where you have to consider yard handling, transportation, and the void former. So what I mean by that, and sorry, is that this application will affect your consideration of what anchors are to be used, but it's not required for the safe working load on devices. So it's just something to consider as you look at the different applied loads. There's different anchor types. You have your facelift stripping, your edge lift, your sandwich panel anchors, your double T anchors, and all of them have different applications. So your facelift anchors are used for lifting anchors out of the casting bed. You have anchors that are placed in the panel prior to the pour, and then they're poured and then they're stripped out straight out of the casting bed. You also have an edge lift anchor. These are erection anchors. You can kind of see in this picture, I don't know if you can see my mouse, but there is I'm sorry. One sec, I see a comment. Why can't a lifting insert be used for an in place? So there was a question that came up. I see, why can't the lifting anchor be used for in place or bracing connection? And the basic idea of this is that's not what it's designed for. A lifting anchor is designed for lifting, and lifting anchors are used, if you think about it, anywhere from 4 to probably 7 times. You have your stripping, you have your yarding, you go back to and then you go to the job site, and then you go to erection. So it could be placed several times. A bracing connection is a permanent connection, and those are designed to have live loads and dead loads applied to them. So you wouldn't want to interchange the two. The lifting anchors are not designed for the loads that a permanent connection are used for. Hope that answers the question. So back to this panel, you have an edge lift. Erection anchors are used in rotation and erection of panels. Anchors are attached to the formwork at the top. So you have rotation, and then you get to an edge lift. There's also sandwich panel anchors. You can see this is one of the varieties of sandwich panel anchors. They're used for rotation and erection of sandwich insulated precast panels. And then you also have double T anchors. So these are for lifting and handling in single or double Ts. They're also used in columns, beams, and girders. So there's a variety of those anchors, different manufacturers of these anchors. So concrete strength, concrete age and compressive strength. This is a pretty good idea of every manufacturer, for the most part, posts data on their anchors based at 3,500 PSI compressive strength and 150 pounds per cubic foot of volumetric weight. So if we convert this, if you say, well, you know, I only have 2,000 PSI when I'm stripping this concrete element. Well, you got to times it by 0.75, and so you have a reduction factor. However, if you have a increased factor, so let's say your next strength is 5,000 PSI, you can multiply by 1.19. The thing that I want to point out here is you always have to consider your limiting factors, your anchor capacity. So it's not just your concrete capacity, it's your anchor capacity. So I hope that makes sense. So if your anchor capacity is only getting, let's say 8,000 pounds at 3,500 PSI, you can't jump up to the 5,000 PSI and expect more out of it because your anchor is going to fail before your concrete fails. So another example of anchor capacity and concrete strength. Let's make it simple. Let's use this 1-ton capacity rated lifter. At 1,500 PSI, you're only getting 60% out of the anchor. At 2,000 PSI, you're getting 70%. 3,000 PSI, you're getting 90%. And at 4,000 PSI, you're getting 100%. So you just have to consider the lifter capacity at your time of stripping and understand what your concrete cones are stripping at when you're ready to lift. So one of the examples I always give precasters is, let's say you're designed for a 4-ton lifter. However, your concrete capacity is only 1,500 PSI. Well, you might need an 8-ton lifter now. So you have to consider that factor and keep in mind what anchor you need. One other thing to consider, like I said, is you have to, is it a concrete breakout or an anchor failure? So anchor capacity, also called the ultimate mechanical load, is the load at which an anchor will fail due to the anchor material rupture. So here's an example of a tested anchor. And what we do is we actually put this anchor in the worst possible condition. So we actually freeze the anchor. So it's ice cold, and then we pull it apart to rupture, and then we test that. So if this is a 4-ton anchor, the mechanical capacity should be 4 times that factor. So if this is a 4-ton anchor, it should fail at above 16 tons before it actually fails. So we don't consider concrete capacity when we're looking at ultimate mechanical load. And one other thing to note is, if we call it a 4-ton anchor, it should match up with a 4-ton clutch. So you can't put an 8-ton clutch or a 2-ton clutch on a 4-ton anchor. Safe working load. So like I said, OSHA has a 4-to-1 safety factor. That's the allowable safety factor for the anchor. So if we're rating this 4-ton anchor at 4 tons, OSHA is going to say, well, it needs to fail at 16 tons to allow use on a precast job site. So ultimate mechanical strength can be divided by 4, or the concrete breakout strength can be divided by 4. So you have to understand from the manufacturer point of view, of where this anchor is failing. Is it concrete breakout or is it material breakout? So there's a safety factor, and the design is for safety. The users cannot use equipment in excess of the safe working load. So there's a safety factor for the buffer zone, which is the failure load divided by the factor of safety. One thing to consider, as you design the inserts and lifters, is what is the failure mode? Is it concrete or is it material? So, for example, an 8-ton anchor may just have a 6-ton pullout in concrete. So you just have to manufacture or examine the manufacturer's published anchor capacity carefully. Safety factors. So kind of what I'm digging at is there's a variety of safety factors as described by OSHA. You have to consider the failure mode. Is it ductile? Is it concrete? The predictability of loads, the quality of products, the human error. And human error plays a huge part in what we're talking about, because an anchor is never placed perfectly. Hopefully it is. There's also economics to consider. What's the price of the anchor versus another anchor versus a different type of anchor. There's the reuse factor, the concrete strength, and sling angles, and also rigging. So reusable hardware such as your clutches, your spreader bars, your rolling blocks, your hooks, those all have a 5-to-1 safety factor. So if it's rated, let's simple math, 4 tons, it has a 20-ton ultimate failure factor. The inserts and anchors have a 4-to-1 safety factor, and the reason for this, it's defined by OSHA, ANSI, ACI, but you think about how many times the concrete element is lifted. So you have your back stripping, your yard handling onto the truck to the job site. Maybe it's moved again at the job site, and then it's erected into its final place. There's also permanent connections. I don't want to dig too far into this, but the simple answer for permanent connections like ferrule inserts, channels, things like that, is there is no current definition of what the safety factor should be. Years ago, manufacturers got together and said, well, we need to design the 3-to-1 safety factor. I think some of you are familiar with the LRFD situation where you're calculating for the concrete breakout strength, and this 3-to-1 safety factor is actually more conservative than the LRFD method. So it's very interesting, and it's kind of puzzling, but the permanent connections, the manufacturers list what the safety factor is and what the capacities are based on testing. Safety factors are determined again by ACI, American Concrete Institute, OSHA, and then ANSI, American National Standard Institute. So we also have a safe working load in concrete. So I always show this to the precast plants, that a 4-ton anchor is not a 4-ton anchor. And the reason I say that, you have different types of 4-ton anchors. You have a spread anchor. I don't list all of them here because there's a lot more than just what I show. But the 4-inch spread anchor gets 2670 pounds, 1.34 tons. You have your 4-ton plate anchor, 6,500 pounds. Now, however, if you used it per manufacturer spec and you include the rebar, now it gets up to 7,300 pounds, which is really important. I'll show it later. There's also a 4-ton tech anchor, which gets 4,305. So there's different types of anchors to use in different applications that will get different ratings. So, and what I mean by this is, if you run out of one type of anchor, let's say you're using this plate anchor here, and you say, well, we ran out of plate anchors, but we have a bunch of 4-ton spread anchors. It's not the same. And so it's really important to understand that you can't just replace one for the other, that they have to stick with what's specified by engineering. Same thing with a dog bone. You don't want to replace, for instance, a 5.5-inch dog bone, which is rated for $69.50, with a 3 3/4 dog bone, which is rated for $39.50. And you'll note here that the only dog bone that's rated for a true 4-ton is the 9.5-inch. And so it's really important. Again, this is at 3,500 PSI, so you'll have different factors. You got to include the concrete strength, your sling angles, and so forth to understand what lifter that you need. You have concrete shear cone capacity too. So one thing I know with precasters that I do this presentation with is that the concrete shear cone, to get a full shear cone and the maximum capacity out of the anchor, it assumes a 1.5 times effective embedment depth, which is what's called the HEF per ACI. So if you have, let's do simple math, a 10-inch tall anchor, you need 15 inches to the edge, either edge, all edges, to get the full capacity of that anchor. Anything less than that, you create a partial shear cone. So now you have different calculation to make. Again, I'm not an engineer, so I don't know all the math, but obviously you can see visually that it reduces the shear cone if you have like an edge lift like this. Or if you get too close to the edge, now you have a partial shear cone condition and you reduce the safe working load. So in this case, on the right-hand side or the middle, you might take this and say it's a 2-ton anchor. Now it's a 4-ton anchor. If you go to a partial shear cone. So there's a lot of factors to consider. So another example, if you have, I've seen a lot of anchors that are spaced closely together. So you want to have the calculation to be accurate. Again, to get a partial or a full shear cone, 1.5 times the depth of the effective embedment depth of the anchor to the wall, and then you'll have 3 times to the next anchor. So anything closer than that, you create this partial shear cone, the picture in the middle, or you create a partial shear cone like an edge lift condition. To increase capacity, you can add tension and shear bars or additional reinforcement. So the anchor reinforcement should consist of stirrups, ties, hairpins, placed as close as practicable to the anchor. If it's off the anchor, then it doesn't do you any good. It creates a short shear cone. But if it's on the anchor, you get the full shear cone. You'll note, one note is if you have a tech anchor, the ear of a lift or of an edge lift type anchor, you'll see these little ears. I don't know if you can see that in the picture, but that prevents spalling. You can also use a shear bar to increase the HEF, the effective embedment of the anchor. And you can see how it wraps around the anchor. And so your effective depth of the shear cone is at the bottom of the anchor as opposed to the top of the anchor. And it helps transfer loads deeper into the concrete. So here's one example that I see at precast plants. And you have, excuse me, you have a standard depth of the anchor with a proper recess on the left with an incorrect on the right. The standard depth of the anchor, the recess member should be flush with the concrete. The standard depth of the anchor should be 5/8 to about 3/4 embedment into the concrete from the top of the anchor. You have the picture on the right showing that the anchor floated or was misplaced, and now it's flush with the concrete. You can see the picture there. So we get this question sometimes from precasters saying, well, what do we do? And the thing I want to show you is if you have, let's say you have a 4 3/4 inch anchor, and here's your shear cone in the white outline. If you place it up too high, you have a new shear cone in the red outline. And so you've reduced your shear cone, which means you reduced your safe working load. So what's the reduction in tensile strength? So originally it was rated for 3590. The current safe working load is now 2977. So you have a reduction of 613 pounds in safe working load. Oh, this does not include the bending moment. So if you have any type of sling angle on this anchor, now you could shear off the anchor. So what happens is if you can go back here, if you engage a clutch on this anchor, it's not going to bear into the concrete, it's going to bear on the anchor. And so you can snap that anchor head. So it's really important that you contact your supervisor, plant engineering, or the manufacturer engineering, or the specifiers to understand what your fixing solution is. So if you see something, say something, it's really important from the plant that they see this. Here's another condition of a partial shear cone that we've seen in the industry. So you have a dog bone anchor and it got tilted in the form. Same thing could happen with the stamped steel anchor. And so the question is it safe to lift? And so on this picture, here's a dog bone anchor and we put a flat edge on it. We measured from 1 inch to half an inch of the bend, and calculated for how close it is to the edge. So in this case, it was a 16-ton anchor. The edge spacing was 24 inches, or I'm sorry, the anchor spacing was 24 inches. You have an edge thickness of 9,300 or 7 inches. So you kind of go down the path here. So safe working load is 9,300 pounds. However, it got tilted towards the edge, which created a new edge distance of 4.5 inches. So we come back up here. So what's the new safe working load? We went from 9,300 pounds to 6,000 pounds just because of that tilt in the anchor. So again, the safe working load does not, even though it's 6,000 pounds, it doesn't account for all the other factors of bending moments and concrete strength, sling angles, and everything else. So again, contact the engineers and figure out what is the fixing solution. So physics of lifting and handling procedure. So there's, you have planning and design, what should happen. You have installation and rigging, what does happen. You have stripping, you have storage and transport, and then you have erection. So there's several steps involved to understand what you're doing. First of all, rigging, always center your loads. With qualified crane operators, I don't see this very often, but it does happen. You want to have your crane over your load. If you have it off-centered, off the center of gravity, then you create pulling, a lot of different forces that can snap the anchors or drag it, and it could cause injuries. Also understand the center of gravity. It looks like most of you are engineers on the panel here, and so you can understand what that does is you have different shapes, different holes or thinness of concrete, the weight, the shape, the size, the location. You got to understand the stripping strength, lifter type, sling angles, and plant hardware. And so, due to all this, you have to understand how many anchors do I need, where do I place them, and so forth. Really important part is sling angles. What I do when I do this presentation in person, it's a little more visual, but basic idea of a sling angle. Let's say you go to the grocery store and you buy a couple cases of beer or milk or whatever. And is it easier to hold those things down at your side, or is it easier to hold them with your arms extended? It's the same way with your crane. So the further out you go, the heavier the thing that you're holding feels. And that's kind of the layman's way to say it. The more technical way to show it is, let's say you're going to pick this piece of concrete and you have a 90-degree sling angle. Well, if it's 10,000 pounds, it'll feel like 10,000 pounds. If it's at 75 degrees off the element, it's going to feel like 10,400 pounds. You go to 60 degrees, it'll go to 11,600, 45, 14,200, and all the way out to 30 degrees, it's going to go to 20,000 pounds. So you have to understand what your sling angle is as you lift the concrete element. You know, spreader beams can be used to increase the sling angle. Rolling blocks can be used to balance it. You can see this picture on the right here. You have a spreader beam going up to the hook, and then down from there you got rolling blocks, and that equalizes the balance. And so you have an equal force on all lines. So it's really important. Now, one thing that the industry notes is that we do not recommend a sling angle less than 60 degrees off the concrete element. So anything less than that, you can obviously see it jumps from 11,600 to 14,200, and we don't want to do anything more than that. On small slabs, you can evenly disperse a 3-point pick. It's like a 3-point bar stool. So you can, 120 degree spacing around the center of gravity, and it'll equalize the load. If you have a spreader bar, if you have an 8,000 piece here and you got a 2-point pick, you're going to evenly divide it, 4,000 pounds total on each pick point. That's going to be the ideal situation. On the picture on the right, you have a 45 degree sling angle. Now it's 56 per pick point. So it's important to understand what anchor you need if you have to jump due to your sling angles. The picture on the left here shows a 4-point pick coming off of one hook. Now, I talked about a 3-point bar stool. Now you have a 4-point bar stool, and you imagine rocking back and forth. At any point, only 2 of those anchors are actually doing the work. Now, as you rock, maybe the 3rd point, either one of these might pick up, or it transfers to those 2 and it rocks the other way. So what you have to account for if you have a 4-point pick coming off of 4 slings, that only 2 of the anchors are doing the work. If you can equalize it using rolling blocks, now you can say, well, 4 of the anchors are doing the work. And so that will greatly affect which anchors you put in that concrete element. Another example of sling angles, this slide's kind of busy, but if you can follow along, we're going to say we're going to pick this piece of concrete here. It's 12 foot by 10 foot by 16 inches thick, 150 pounds per cubic foot. Well, it weighs 24,000 pounds. Now, the thing we have to account for is that form adhesion that we talked about. And in this case, the form adhesion is 20 pounds per square foot. So we're going to add 2,400 pounds to this concrete. So now the combined load is 26,400 pounds. Only 2 of the anchors are doing the work. We also have to use a sling angle factor of 45 degrees. So we multiply it by 1.42, divide by 2, and each anchor needs to carry 18,744 on a 26,400 pound load. If you used a 30 degree sling angle, each anchor needs to use 26,400 pounds, which means each anchor needs to carry the full weight of that combined load. So it's really important to understand what your sling angles are and what you have available, so you use the proper anchor. The rigging must comply with the spec from engineering. Another example of 4 inclined slings. Now we're going to use a stripping and dynamic force multiplier. So same idea. You have a sling angle of 60 degrees here. We got 24,000 combined or dead weight. This thing's been stripped, and now we have a dynamic force multiplier of 1.5. So you have a combined load of 36,000 pounds. Only 2 of the anchors are working because you have 4 inclined slings. So each anchor needs to carry 20,880 per anchor. Now we change it to a spreader bar. So we went from 4 inclined slings. Now we use a spreader bar instead with rolling blocks. Now each anchor only needs to carry 10,440. Does that make sense? So I hope you understand that. So if you change your rigging to a spreader bar with rolling blocks, you can downgrade your anchor from a 20,880 per load to a 10,440 per load. Again, stripping is very important. The lifting point location is defined to keep stresses within allowable limits to ensure no cracking or controlled cracking. Your exposed surface will be the limiting factor if stresses are different in both faces. So stripping should consider orientation of members, which way the members are facing, handling and erection, including any necessary rotation. So if you're going to rotate this panel to vertical, you have to consider that as well. And then also adhesion force and elements with eccentricities like holes or odd shapes may need additional lifting points and or strong backs. So there's different types of stripping. You have an edge pick, which is kind of, you're peeling the concrete off the form. So you have anchors along one edge, you have opposite edge continuous support, and it's ideal for the thin elements that are erected and stored vertically. You have a face pick, or commonly referred to as back stripping, where anchors are placed evenly along the face to carry similar loads. You have higher adhesion to the form, ideal for large panels and beams. And a lot of precasters still use a tilt table. And the elements are picked from an angled position, and basically it reduces your lifting stresses, and it reduces also the adhesion to the form. So here this video is playing of a lifting and rotation. So what they're doing is they've already stripped it. It's in the yard. They're going to lift this panel from the casting bed of the transport truck. A spreader bar here in place, and they have separate lines. Now they're going to lift and rotate this panel to vertical, and you can see the load has been transferred to those face anchors, to those edge pick anchors. Well, yarding and storage is important as well. Storage should be done to support closer to the lifters used for stripping and handling to avoid additional load conditions. So if you have long span beams, it should be avoid lateral buckling. You could have warpage during storage due to temperature differential, shrinkage, or creep. And it can also be minimized by limiting sun exposure to one side and paying attention to the storage tilt angle. But transportation is another factor. You have weight limitations for dynamic effects due to the road conditions. The normal trailer payload is 20 tons, 8 foot by 40 foot. Low boys increase the height from 10 foot to 12 foot. And erection is simplified if the transportation has the same orientation, which can't always be achieved, but it is important to consider. So stresses during transportation should be close to the ones during stripping and handling. And if you have eccentric elements, you may need additional lifting points and or strong backs as previously discussed. So erection. You have your center of gravity must be between picking points to prevent sudden shifting of loads. So you don't want to just you don't want to have a shock load as you rotate a panel. 2 crane lines should prevent uncontrolled roll on roller blocks by offsetting the pick points or by using chain drags. And the eccentricity must respect the stability equation below. So safety best practices. Inspection procedures, insert care and maintenance, sling angles, bail position. So a failure happens when the safety guidelines are not followed. And again, safety is not an option. We strongly consider everything I've talked about to be life safety devices. And so they must be used with the utmost care. So how do you eliminate hazards while lifting? So the general considerations: you lift the product a few inches off the ground and inspect the rigging. Make sure there's nothing caught up. You don't have clutches bent over the concrete. You protect your slings from your sharp edges. So there are edge guards to consider if you're using slings. Plan to lift and know where you're going to deposit the load. So you don't want to pick a load and not have a plan of where to put it. Also plan an escape route. So as you're lifting it, the people on the ground are not standing in front of stationary objects or are not trapped in a confined space. If you're placing the load on dunnage, have it ready. There's a report that came out of OSHA of someone that lost some fingers because they placed dunnage under a suspended load. You never ever want to put yourself under a suspended load at any time because you don't know what's going to happen. If you have to move the dunnage, use a secondary piece of dunnage or use something else to move it. And always treat the rigging as though your life depends on it, because it does if it fails. Inspection procedures. So you have an anchor here with a crack in it. So check for cracks, defects, missing welds, or deformed shapes. You have a V anchor that looks more like an L anchor. And so if you see something like this, obviously it's not safe to use. Your recess members. I've seen some doozies out at different plants, but one thing that I always remind precast plants is if you keep them clean and you grease them, you can use these things for a long time for the reusable ones. Also check the finish of the anchors, so you can, is it hot dip galvanized? Is it plain? What's supposed to be the finish of the anchor to make sure that QA QC process begins with the lifting and hardware. One other thing to note is on these plate anchors, these are very commonly used for back stripping. That QA/QC checks to make sure that the reinforcement around these, the recommendation from manufacturers is that we use a number 4 bar, 18 inches long. And you can see in this, on the left here, you have your bars underneath on the actual plate. On the right, you can see they're on the ground, so that does no good for the shear cone. You're only getting the shear cone this way. You're actually getting a partial shear cone. This way, you actually get a full shear cone. The other thing to note is what your clutch looks like. So clutches can bend if they're used improperly. And I've seen plants that have clutches that have been around for 20 plus years. In this instance, on the picture, you can see it's beyond the bend. Always want to check with your manufacturers of what the inspection procedure looks like. And I'll show you a slide of one of the manufacturers. So failure to do so may result in damage to the anchor, which could result in the anchor failure, injury, or death. Defective clutches must be removed from production floor and destroyed. It's really important, and I've seen it a few times where an anchor is bad and they say, well, it's bent, and they throw it off to the side. Well, somebody else might come along and take that and use it. So as opposed to doing that, make sure it gets off the floor and actually cut up or destroyed. So in this case, I'm showing a ring clutch QC gauge. It's a simple gauge that manufacturers can use. And basically the H stands for handle, the B stands for the bail. So on a clutch, you have, here's the bail, and this little part here is the handle. So if the bend is beyond acceptable, you put that gauge up to it. If it's beyond 10 degrees, the clutch is no good. If the handle is beyond 15 degrees, then you can replace the handle, but get the bent handle out of the plant. One other thing to note on these cable loops is the proper embedment is 2/3 in concrete, 1/3 out of concrete. And this, check with your manufacturers, but this is what creates that full shear cone. So if you pull it up too high, you lose your shear cone. If you put it too low, you might not be able to get your hook into it, or you could snap the cable. One thing for insert care and maintenance, do not modify at any time welding, cutting, grinding, or introduce chemicals. Also, it's very important to use caution if they're using foam oil around the lifter or recess members, because it'll act as a bond breaker between the lifter and the concrete, and that's what gives the lifter its strength. Like I said, sling angles should be limited to minimum 60 degrees from horizontal to limit loads introduced to the element and total load in sling. So load from low sling angles may cause instability of element or tear out the anchor or break out the concrete. Bail position is very important, especially for the stamp steel anchors. This is one example here that you want to have the handle engaged in the concrete. You want to have the bail, which is this part here, vertical, and you don't want to have it over the concrete. I'll have another picture here. So here's your correct on your edge lift. Your bail is vertical. You can connect with your hook and lift. Or if it's in the side here, you have your handle engaged and your bail vertical, and you can connect with your hook. The wrong way to do it is this picture on the right, where you have it kind of caught in the donut. And now if you go to lift like this, you can create shock loads, you can bend the clutch, you could tear out the anchor. So make sure that it's engaged properly. So key takeaways. You should be able to define the different styles of lifting hardware, like engineered lifting systems, hook lifting systems, stamp steel, dog bones, and equipment and their applications. Describe the impact of concrete strength on lifting hardware and the capacities. Differentiate between safe working load, ultimate load. There's the basic physics of lifting that we went over, sling angles, number of different lift points, center of gravity, and identify the signs of wear and damage on hardware and equipment, and outline the safety best practices for lifting and handling. So great benefits about specifying precast. This is a specifier webinar. You can and should rely on the precasters for answers and support with respect to all these topics that I just went through. Precasters are fantastic at being able to do these calculations, determine the right lifters, figure out center of gravity, etc. And you can have peace of mind when you use the precasters for concrete lifting. With that, I think that concludes the presentation. I'm happy to answer any questions and love to see what you have. Any questions at all? I'll keep you anonymous, so we you don't have to. Yeah, please reach out and let me know what you, or if I'm missing something, if you think I said something wrong, I'd love to hear from you.
I'm sorry, I do have some questions here. So okay. The first question we had was back on slide 22.
Okay.
And that question asked, is the contractor or the precaster responsible for member stability during erection?
Good question. Okay, sorry. Oh, I skipped it. So slide 22. So it's here.
I'm sorry, the question is the contractor or the precaster responsible for member stability during erection?
For the member stability? For the anchor stability?
Or are we talking about bracing?
The structure stability.
Nimron, what do you think?
Well, the contractor typically does, and so there's some folks that do self-install in some areas, but the contractor is the one who actually does the erection and does all the welding or structural connections of each product as it's put in place. So my thoughts and my personal experience have been is that the contractor takes that on. Assuming that all the design elements on where those embeds and the structural connections are in the right place.
I think a big thing to consider here is that with any failure, you're going to have an investigation, and it's going to go back to, was the thing placed properly? Was the concrete the right density? Was the erection proper? So there's a lot of, it's kind of a broad question. I apologize for, I don't have a precise answer, but it's got to go back to how is it designed, and kind of each step from there is going to determine who's responsible for what happened.
Okay, perfect. And then on slide 26, we had 2 more questions.
Okay.
And the first one is, what do designers typically use as a form suction load?
That's a fantastic question. Let's say that, I mean, like you can see in the chart here, it really depends on the form. It also depends on your form release, what you're going to use for a form release. And so you can see there's exposed aggregate with a retarder. There's a smooth form with a release agent. So there's different factors that, PCI recommends. Now, I guess in my personal experience of what I've personally seen out of actually using load cells to see what the form suction is, it can be anywhere from 20 to 100, 150 pounds per square foot. If you have different elements like a double T, you have it changes as opposed to a flat panel, for instance, it changes how much form suction you're going to get out of that. But yeah, I mean, it's best to definitely get with the manufacturer and find out, what kind of you should receive out of that form, depending on the project. I hope that helps.
Okay, and then, sorry.
Yeah, good.
We had a second question on slide 26, and that is there a formula to quantify the value of the form suction load?
I'm not aware of that myself, but there are factors that have been proven out that were presented here, and for other materials that you may be stripping from. So the factors, I'm not sure exactly where those were generated, but there are specific factors that have been used throughout the industry to determine how to calculate into the suction force depending on what you're lifting off of and how you're lifting it.
Yeah, I mean, really the answer is it depends. Unfortunately, there's not a straight answer, and the reason for that is there's so many different types of concrete elements. There's so many different types of forms. Are you using a steel form, a concrete form, a wood form? All that will affect what your multiplier is as far as stripping forces.
Okay, and then moving forward to slide 30, we had a question, and the question asked, the anchor capacity is usually not stated in vendor guidelines. Do engineers have to estimate that?
That's more of so where you'd have to really look for that is if you're trying to go up from what the manufacturer is saying the working load is. So let's say, for instance, the manufacturer says this anchor is good for 4,000 pounds of 3,500 psi concrete, and the engineer that's working on this is saying, well, I have 5,000 psi. So if you're trying to go up, that's where you need to contact the manufacturer probably and find out what the failure mode is. And that's the most important part is understanding, is the failure mode concrete or is the failure mode the rupture of the anchor? And that'll be your limiting factor. I mean, and to kind of go deeper on that is you want to understand what all your limiting factors are. Right? For instance, I've been at a precaster where they were trying to lift a very heavy piece of concrete. However, they didn't have the proper spreader bar to lift this thing. And that was the limiting factor. And so we had to change out, find a different spreader bar to make sure that we were able to lift this thing. So you always want to go, it's kind of, you want to go back to your weakest link before lifting. Imran, I don't know if you have anything to add to that.
No, that's a good way to put it, yes.
Okay, perfect. And then moving forward to slide 31, we had a question that asked, can you use extra confinement reinforcement to increase concrete failure mode capacity?
Absolutely. And that's where your engineers will are extremely valuable because, you know, one thing I should have pointed out was manufacturers, when we state a safe working load in our handbooks, we are stating it at the worst possible condition. So what we've tested for is no reinforcement. And so if you add reinforcement, you know, that's where an engineer comes in, or you can get with the manufacturer's engineers to say, this is our reinforcement, what we're going to use, and what's our capacity based on that. And again, it goes back to what's your limiting factor of concrete versus anchor and all that. But so if your anchor capacity is fine and you can bump it up using reinforcement, such as either rebar, mesh, it could be a shear bar or a tension bar. You know, those are things to always consider. Absolutely.
Okay, and then skipping to slide 42.
Okay.
Are anchors typically made of galvanized or stainless steel for exterior exposures?
Depends on the anchor. I mean, they can be made to order. I mean, different manufacturers have different finishes, so you know it's important to understand what you need. The only thing I would point out is which it's a question I've received quite a bit, and the only reason I'm pointing it out is if you have like a ferrule insert, which is like a permanent connection national coarse threaded insert, and you specify hot dip galvanizing, what happens is that has to be retapped. Now, if it gets retapped, that strips that hot dip galvanizing off of there and offers no protection. So what we recommend is, you know, if it's that type of anchor, then you want to use electro galvanizing. However, for lifting and handling anchors, it could be plain or mill finish, or it could be hot dip galvanized. Yeah.
Yeah, and sometimes like coil inserts that are used for lifting and handling are oftentimes required in stainless steel for applications on coastal areas where there is a significant amount of potential for corrosion. So coil inserts are predominantly the type that we see, that I've seen in the industry, that require sometimes to be made out of stainless steel, and more often than not are. But those are also available in hot dip galvanized. But yeah, plate anchors and such, and the other kind of dog bone type of anchors are usually hot dip galvanized if corrosion is a concern.
Okay, and then we'll move on to the next question. This one is in reference to slide 44.
Okay.
And the question is, in your opinion, do lifting devices develop full capacity if they are wet set after placing the concrete, or should they always be installed in the rebar prior to the pour?
Boy, this is a great question. And we talked about, I have a couple videos on this. I guess the easy way to say it is wet setting is kind of an art form. And what I mean by that is they really have to understand what they're doing. And so if you wet set too early, the anchor could sink. If you wet set too late, now you don't get proper concrete consolidation. If you wet set at the right time, you will get proper concrete consolidation. However, the only thing that I say from a manufacturer standpoint is that we don't recommend it. However, again, everybody in the industry does it. So it's kind of a double-edged sword. But the recommendation is to tie it in so you know where the anchor is, you don't have it misplaced or anything like that. Because there are some variables with it, and the person that's placing the anchor, you have to make sure that one, it's measured out, where's the anchor going, what place is it in, and that it's placed that you get full embedment and full engagement with the concrete. Imran, I don't know if you have anything to add to that.
Yeah, I mean, there's the pitfalls. Oftentimes, even if you place them in the right place and at the right time, it's oftentimes, you'll see, and you'll see this in Clint's presentations, safety presentations, is that people put them in off angle instead of being perfectly vertical like they need to be, or as vertical as possible. Sometimes they do go in off angle, and that, as Clint had mentioned in his presentation, does reduce your load capacity, and so that has to be taken into account. So it's always best if you can avoid wet setting, but as he also mentioned, wet setting is very common.
All right, perfect. And then we got quite a few questions there at the end, so I'm not sure what slide this is in reference to.
Oh, great. Yeah, go for it.
One question asks, how do you attach the dog bone clutches?
Oh, okay. Let me see. Am I stop sharing now?
Yes.
Yeah.
Okay, let me, I do have a slide on this in a different thing. Give me just one second. And I don't know if you want to speak to this, but basically,
Well,
it's, yeah, go ahead.
No, go ahead, Clint.
I mean, with dog bone clutches, the idea is that there's an ear on a dog bone clutch, and you want the ear to be facing your hook. And I'll show you in just one sec. Let me find it. Okay. Let me take out, there we go. Okay. Screen. Can you see my screen now?
Yes, we can.
Okay. So here's a dog bone clutch going up to a hook. On the left, you see that ear of the dog bone clutch is engaged in direction of the hook. If you engage it in the opposite direction, what happens is that ear can, as you rotate, that ear can lift and pull out. And so what we always say is make sure the ear is facing the point of lift, and then it's ready to go. Because if you look at the picture on the left, as you lift, that ear engages in the concrete, and it actually creates 3 points of lifting, and then it's ready to lift. I hope that makes sense.
Okay, perfect. And we had a couple more questions come in at the end. The first one is, are there lifting points that can be designed for bracing use after erection?
The recommendation is no. Like I said, is that you don't want to you don't want to have the same insert be used from lifting to permanent connection. Now we've developed, there are products that are developed. It's not commonly used, so but typically you'll have a brace, like a coil type insert for your bracing and a lifting insert for your lifting.
Okay, and then we'll do just 2 more questions here. What considerations must we have when we use strips?
When you use what?
Strips.
Strips. Sorry, I'm not quite sure I understand.
Yep.
That's okay. We can go on to the next. So the next question
What was
asks,
that?
Go ahead.
No, I was just asking what that last word was on that last question.
Strips, S-T-R-I-P-S.
I guess if they can maybe clarify what they're asking, that'd be really helpful. I'm not quite sure what they mean by strips.
Okay, we will answer another question as we wait. And the question is, are the J-form anchors commonly used?
Are the forged anchors?
J-form.
J-formed anchors?
Yes.
J-formed anchors.
I'm not entirely sure what a J-formed anchor is.
Okay.
I'm not sure what that is. It may be used for smaller infrastructure.
Yeah.
I didn't put all the anchors up there. There are other types of anchors that people use. There's what's commonly referred to as an R anchor or U anchor. There's coil lifting. So there are other types of anchors than what I showed, but the ones that I did show are what's commonly used in the industry.
Yeah,
okay.
The nomenclature for a J anchor is not something familiar to me.
Okay. Well, we'll get back to the last question. We did get some clarification, and that question was, what considerations must we have when we use straps?
Oh, good question. Yeah, I didn't really cover straps just because we're not a manufacturer of them. From what I've seen, the most important thing that I've seen is understanding the wear of your straps and protecting your edges. And those are, from what I've seen within the industry, as far as maybe the 2 most important ideas, that there's edge guards that can be used for straps, and then also inspection of the straps before lift to make sure that your threading's not torn apart, or that it is safe to lift. That I think is really important. Also, obviously understanding what your safe working load of those straps are. Imran, if you have any.
Yeah, I would agree with that. Yeah, in fact, the most important thing I've ever been taught was to check for the quality of the strap, make sure there's no fraying, and then also your edge conditions, and make sure you use edge guards if there is any such interaction. So that's as much as I've been involved in that side.
Okay, all right. Well, with that question, we're going to go ahead and wrap up the Q&A session. Imran and Clint, do you guys have anything to add?
No, feel free to reach out to me or Imran if you guys have any questions, or NPCA. I'd love to get your feedback or any questions that you have as we move forward. The whole idea of this presentation is that we want to make the industry safer. If this prevents one fatality, then it's absolutely worth it to both of us and our industry to make sure everybody goes home the same way they went to work. Emron, do you have anything to add?
Yes, no, and we really do appreciate everyone's attendance, and we would welcome any further follow-up or questions that you may have. Please don't hesitate to reach out to us.
All right, perfect. And to everyone else, thank you for taking the time to attend this webinar today. Your opinion counts in everything we do, and we appreciate your feedback. We will be sending out a link for viewing the playback of today's webinar, along with a link to a brief evaluation for you to complete. Please note that you will receive your certificate of completion via email from me within 5 business days. If there are no further questions, this concludes today's webinar. Thank you for participating.